Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. My name is Muhammad Ariff KHAIRUL BASHA. Along with my team members, Muhammad FAIZ bin ROSLAN, Muhammad WAFIYYULLAH bin SHAHRIN, Muhammad IKHWAN AIMAN bin Muhammad FAUZLI, Muhammad ILHAM bin JELANI, LOGEND anak lelaki RAJAH, Nur Shifa binti Muhammad FESOOL, Nur INSYIRAH QISTINA binti KAMSOL, and Nur SYAMILIA AINA binti Muhammad NAZRI. Today, we will be presenting our network analysis and design project from FTMK for our organisation SMK Seri Mahkota Umbai Melaka. This project is supervised by our lecturer, technologist Dr. Azman bin Ma'arif. So, let's start with our presentation.
Assalamualaikum and hi, my name is Insyirah and I'll be introducing the school that is the focus of our network redesign project, which is SMK Seri Mahkota. The school is located in Umbai, Melaka and was established in 1973. It operates under the Ministry of Education as a government secondary school and serves as a key educational institution in the local community. Currently, the school has a total of 971 students. They are supported by 97 teachers and 14 administrative and support staff, including personnel from the IT and maintenance departments. The school is equipped with a wide range of facilities. This includes 54 classrooms, 12 science laboratories, 3 kemahiran hidup workshops, ERT rooms, several computer labs, a large hall, a well-stocked library, sport field, and canteen. The school's vision is quality education, educated people, prosperous nation. This reflects their commitment to academic excellence and national development. However, despite having these facilities, the school faces major challenges in terms of its digital infrastructure. Internet connectivity is often unstable, the hardware is outdated, and there is very limited use of e-learning tools. These issues affect both teaching and administrative tasks, making it harder to adopt modern, efficient methods in daily school operations. Through our project, we aim to address these problems by designing a modern, secure, and efficient network system that supports both teaching and administrative needs. Next, Shifa will explain the specific problems in more detail and introduce the objective and scope of our project. Thank you.
Assalamualaikum and hello everyone. I am Shifa and I will be explaining about our problem statement, objective and the scope of this project. Let's start with the problem we found at SMK Sri Mahkota. The school is facing few major challenges. The first one is unstable internet connection. The Wi-Fi is weak with slow speed and frequent disconnection. This affects online learning and day-to-day activity for both student and teacher. Number two is outdated equipment. Most classrooms are still using old computer and projector. These devices are not suitable for current teaching method and make it harder to use modern tools like video, interactive lesson, or e-learning platform. Number three is manual data management. Important tasks like recording student attendance, inputting mark, and handling schedule are still done manually using paper or Excel. This takes more time and can lead to mistake or lost data. Now let's talk about our objective, what we aim to archive on this project. There are three main goals objective for this project. Number one is improve Wi-Fi speed and coverage. We want to upgrade the school Wi-Fi system to make sure there is fast and stable internet in all areas of the campus. Number two is replace outdated teaching tools. We plan to replace outdated computer and projector with new PC, interactive whiteboard, and other modern teaching tools like that make lesson more engaging and effective. For the number three is digitalize the school system. We want to build a centralized system that combines admin work and teaching needs. This includes automating tasks like attendance, grading, scheduling, payroll, and even helping teacher with lesson planning and student communication. Lastly, let's look at the scope of our project. This project covers the main teaching and administrative area, such as classroom, laboratories, teacher office, the school library, and the main hall. The implementation will be done in three phases. Phase 1 is network improvement. On this phase, we will install a new router and access point to boost Wi-Fi coverage and speed. For the phase 2 is device upgrade. On this phase, we will replacing all devices with better one that match today education need. Phase 3 is IT support and training. This phase we will provide training for teacher and staff so they can use new system confidently. And we will also include a maintenance plan for long-term support. That's all from me. Now I will pass it over to Shamilia, who will explain the system design. Thank you.
Assalamualaikum, I'm Nur Syamilia. So on this slide, I will present about the current logical design and the future logical design of our network infrastructure. Let's start with the table on the left. This is our criteria of technology evaluation. It shows the detailed specification for each composite flow label CF1 to CF5, as well as a one flow label BB1. Each row lists the reliability, capacity, area type, maximum capacity needed, and the estimated number of future users. From this, we can see that all connections require a very high reliability of 99.98%, which is essential of uninterrupted performance. The LAN segments vary in capacity from 20 Mbps up to 55 Mbps, depending on the expected traffic and user demand in that area. The one connection BB1 is designed for higher capacity needs up to 100 Mbps to support 30 future users. Now, let's focus on the right side of the slide, which presents our logical network design in detail. At the center of the design, we have the main server located at FB3. This acts as the core hub, connecting to various buildings and functional areas across the campus using LAN. Each facility block, labeled from FB1 to FB17, connects directly to the server. For example, FB1 handles the WAN connection and links to the internet. FB2 is the office and is connected through both CF5 and BB1 composite flows, showing that it plays a critical role in both LAN and WAN traffic. FB4 to FB12 are various workshops, classrooms, labs, and the library, all directly linked to the server via multiple composite flows such as CF1, CF2, CF3, and CF4, indicating different bandwidth and reliability requirements. FB6 is a dual-purpose block, a bakery and classroom, while FB8 houses the library and science lab, showing multifunctional connectivity. FB14 to FB17 includes facilities like the hall, computer lab, science lab, and canteen, also all directly connected to the server. Even the most at FP13 is part of the network, which reflects a comprehensive coverage across the entire campus, not just academic buildings. What's important here is that every connection is clearly labeled with the corresponding composite flow IDs, like CF1, CF2, CF3, CF4, and so on, which helps ensure that the bandwidth and reliability requirements identified in the left table are met in practice. Overall, this logical design ensures high performance, centralized control via the server, and future scalability by covering academic, administrative, and recreational blocks. Thank you.
Okay, now we move to interconnection mechanism. Good morning, I am Ilham and I provide a detailed explanation of interconnection mechanism which ensures seamless communication across the network. This slide is essential for understanding how different network segments are linked. The diagram on the left The degree of hierarchy is illustrated is a campus layout featuring router and switch connection key areas, the office, library, and science lab. Canteen and green field represent the campus boundary. Hard boundaries and soft boundaries are marked to define network zone. On the right, the interconnection mechanism is detailed with a diagram showing routers and switch linked these areas, supported by two tables. The first table lists location-specific flow concentration. The ISP office has 1-to-1 ratio with no hierarchy and no alternate patch, while the office internal blocks, workshop, canteen, computer lab, library, science lab, classroom, hall, mosque, sports store, and field show a 4:1 ratio with medium hierarchy and one primary patch. The second table on degree of redundancy highlight high redundancy for classroom and labs, with multiply connection pairs ensuring fault tolerance. This mechanism is designed to optimize data transfer rate, minimize downtime, and provide a reliable network backbone, which is vital for a busy educational institution like SMK Seri Mahkota.
Hello, my name is Mohd ROSLAN, and I will talk about network management and security issues, a critical aspect of our project. This slide addresses the weakness in the current network and our proposed solution. The network diagram shows a central office linked to classroom, labs, the canteen, and the field with a router handling traffic and switch providing connectivity. The existing setup the existing setup lack effective security protocol, leaving it prone to illegal access and data breach. Our strategy includes several layers of protection. There is network security features, authentication to verify user identities, firewall block unsafe traffic, and a DMZ, the military zone, to isolate public-facing service like the school website for internet network. For physical security, we propose access control system with keyboard with KeyCard entry to restrict unauthorized physical access to server room. Power and backup system including uninterruptible power supplies to maintain operation during outage, and environmental safety measures such as temperature control and fire suppression to protect hardware. This enhancement will ensure the data integrity, protect sensitivity student and staff information, and maintain network availability, addressing the school current security shortcoming effectively.
Hi everyone, I'm IKHWAN, and I'll provide a comprehensive overview of the wiring scheme and cabling use, which forms the physical foundation of our network design. This slide is crucial for understanding the infrastructure supporting our digital upgrades. The design employs a star topology where all blocks, administrative offices, laboratories, classroom, the library, canteen, hall, mosque, and sports store are connected to a central switch housed in the server room. This topology simplifies network management, allows for easy troubleshooting, and ensures scalability or future expansion. The cabling specification calls for Cat6 UTP, unshielded to pair cables for all connection, chosen for the ability to support data rates up to 1 gigabyte per second over distances of up to 100 meters. This high-speed capability is essential for a school environment, enabling fast internet access for educational tools, video streaming, and administrative tasks. The diagram visually traces this connection with red lines indicating cable route from central switch to each block, ensuring comprehensive coverage and reliability across the school. This robust wiring scheme is the cornerstone of our plan to modernize SMK Sri Mahkota's network.
Good morning, I'm Logan and I'll present an exhaustive IP addressing plan, a vital component for organizing the network efficiently. This slide ensures that every device and user group have a designated and secure address space. The major network address is set at 192.168.0.0/16, providing a broad IP range that we have subdivided into specific VLANs. VLAN 10, designated for admins, uses the subnet 192.168.10.0/24 with a gateway at 192.168.10.1 and an IP range from 192.168.10.2 to 192.168.10.3. 10.50 allocated for administrative PCs, proxy servers, database systems, email servers, and attendance tracking software. VLAN 20 for teachers operates on 192.168.20.0/24 with a gateway at 192.168.20.1 and a range from 192.168.20.2 to 192.168.20.10, supporting teachers' laptops in labs and classrooms. VLAN 30 for students uses 192.168.30.0/24 with a gateway at 192.168.30.1 and a range from 192.168.30.2 to 192.168.30.20, covering student Wi-Fi devices, lab PCs, and library computers. Additional VLANs include 40 for guests, 192.168.40.0/24 with a gateway of 192.168.40.1 within the range of 192.168.40.2 to 192.168.40.50 with restricted access. VLAN 50 for CCTV, which is 192.168.50.0/24 with a gateway of 192.168.50.1 between the range of 192.168.50.2 to 192.168.50.3 for IP cameras and NVRs. 60 for PA system, 192.168.60.0/28 with a gateway of 192.168.60.1 with range of 192.168.60.2 till 192.168.60.14 for controllers and speakers. And VLAN 70 is for network monitoring with 192.168.70.0/28 with a gateway of 192.168.70.1 that has range from 192.168.70.2 till 192.168.70.14 for SNMP and NMS, and 99 for management, 192.168.99.0/28 with a gateway of 192.168.99.1 range from 192.168.99.2 till 192.168.99.14 for switches, APs, routers, and firewalls. This detailed segmentation enhances security, reduces IP conflict, and supports the school's diverse operational needs.
Good morning, my name is Wafi and I provide an in-depth explanation of our routing strategy which ensure optimal data routing and network resilience. This slide is designed to balance load and maintain connectivity across the campus. As you can see on the diagram, the network layout features a default router as the central hub connecting various areas including the office, classroom, canteen, library, science lab, hall, mosque and field with hard boundaries and soft boundaries delineating network zones. The table on the right defines the degree of hierarchy: 9 1-to-1 flow concentration, and low 2-to-1 and 3-to-1, medium 3-to-1 to 5-to-1, and high 6-to-1 or higher. Correlating with the concentration of network, flow. Second table is specific location, which is the ISP office has a 1-to-1 ratio with no hierarchy point, while the internal blocks, which is workshop, canteen, computer lab, library, science lab, classroom, hall, mosque and sports store, including field, show a 4:1 ratio with a medium hierarchy and one primary path, ensuring a balanced load. The degree of redundancy diagram illustrates multiple connection paths for critical areas like classrooms and labs, enhancing fault tolerance and minimizing the downtime. This strategy is meticulously crafted to support the school high traffic demands, ensuring efficient data delivery and network stability.
Now it's time to conclude our presentation. We have successfully identified weaknesses in SMK Makoto existing network infrastructure, such as poor connectivity and outdated system. Our solution includes a structure VLAN-based logical design that improve performance and segmentation, as well as cost-effective, secure, and scalable physical network layout using PoE and structure cabling. Um, the impact is significant, stronger, more reliable Wi-Fi and internet connectivity across all teaching and admin areas, including centralized system for efficient management, attendance, and communication. For better teaching tools, we improve data access, scalable, secure network for a ready long-term digital transformation. That's all from us. Thank you for watching.